Yo igual me empiezo a dar vuelta y a mirar para atrás.
I shouldn't be talking because I haven't started yet, but hello. Well, it's a pleasure for me to be here. Second time that Nicolas pays me the honor of having a talk, and I had thought about this, and I've already thought about the next one next year. Last year, I talked about automatic learning and what it was all about at a time when machine learning wasn't that fashion. In the next years, well, in 2015, I put a tweet saying, get prepared to listen or to read about these two letters, AI, ad nauseam. I think I quite made it there. And we have to think about automatic learning. It doesn't change the real thing at the end of the day, but it's the way how this ecosystem behaves. Now, I'd like to make, I made a talk about why I thought that from the, in a certain way, we could move the border of what we understood for computing. I'm sorry, I can't see the end. I'm almost killed myself. Well, but the foundation is practically the same. The rationale is practically the same. But in our theoretical toolkit, well, we didn't have that. And that's what I tried to explain then. And this is the natural continuation of interest, particularly for somebody who is wearing two hats, the academia and the Ministry of the Industry, where we establish the productive policies of this country. What policies should we work on, and how should we define them to move on? So I thought it was interesting to talk about automatic learning in the real world. Now, in the context of this talk, it means the productive world. This real world means the productive world. But these concepts may be applied in any other real world, for instance, governments or social issues, or how can we use this same type of things, and you'll see that you can apply them and transfer them to those worlds. But the real world is the productive world. It's not the only one that exists, but it's the one we're going to be referring to. I was delighted. I said it personally. I love the logo, the motto of this event. And because it's the explanation that Nicolas gave us solved a sort of dilemma that I had as a researcher. It's true about for 20 years I've been doing research of natural language. I know quite a lot. It's true. It's simply because I've been reading the same thing for a long time. And when I see how much we are talking about it and how superficially we're talking about this, it's horrible. But on the other hand, I'd like to say that it's wonderful, and the world is truly changing because of that. And I think that the key issue that at the end of the day, the game is defined with the things you do, not with the things you say. And I'm quoting Nicolas literally. A Uruguayan company that for 28 years has been doing things. And we really have to see whether we resist the test of time. And that's what defines the game. Now, in the meantime, we may have a business model, you know, where I sell a startup and I get money and so on. But I'm not changing the world. I'm not changing the productive world. What changes the productive world is what's happening in the world of technology, things like that. I've taken this statement from a startup I made. I think it was about football statistics. It doesn't matter, but it says uses streaming data and applies machine learning, deep learning, and artificial intelligence to capture and analyze this data, making way for innovations in everything. Why do they talk about machine learning, deep learning, and artificial intelligence in the same sentence? Is there a union of if in that way Bezos would give you something big? They don't know what each one of these things is. I mean, there's a lot of noise there, and we may be thinking that from the productive way, wow, this is wonderful. Or on the other hand, I mean, well, this is nothing. They're inventing, they are selling smoke. This is nonsense. And what I really want to convey is that it's neither one thing nor the other. But let's look at the noise. But talking about noise, the NIPS conference is the Neuroinformation Processing System. It's been there for 20 years, and that's where they would send the articles of the neural networks, deep learning and all that. It's not new, it's 20 years old. Now, the conference this year was sold out in 11 minutes, 38 seconds. The main conference sold out in 11 minutes, 38 seconds. Everyone wants to talk about neural networks, and several researchers were outside the conference. They don't know very much why, but they want to be there. It's hyper-theoretical as a conference. And I'm going to be talking a little bit more about NIPS, just remember. And then we have these drawings where artificial intelligence seems to be humanoid. I took it from the internet. I don't know why someone would like to disguise a robot as a person to make a cube, which in fact you can do when you're in first year of high school. There are lots of things about artificial intelligence, that it's something big and that it's worthwhile, but it's represented by things we don't know why. I don't know if I'm making myself clear here. Now, what's happening is it's not the same, but it's part of a process that is almost 100 years old.
1936 con Alan Turing, con la...
With machines, with computing, with communication, with Newman and the notion of Princeton machines and the internet and then the web and then Google and then Facebook and then... So we are going through a technological change process, but it didn't start 6 months ago. And what we call artificial intelligence now, as a general concept, is what people do that computers don't do, because when they learn how to do it, it's no longer AI and so on. But it's something that is part of a process. Now, what's happening is that there are some important things occurring, and we've got a new toolkit, and that's what I said in my previous talk last year, that allow us to do things, new things. And that's what I want to talk about, is this concept, and that's why I use this term of automatic learning, because I know how to define it. It's programs that they learn on the basis of experience. The more data they have, the better they are. And I think that we all know about. So what I'm going to be talking about, automatic learning. And to simplify matters, why is it that I want to simplify it? Because then I want to apply it, because if I don't know what something is, I can't apply it. So when I talk about automatic learning, 99.9% of the times when you listen talking about this, we're talking about classification, either about classification, that is, I want to allocate a discrete category to something. I've got this image, and it's a dog or a cat, and that's a category. Or a regression problem. How much is my house going to cost, or how much can I sell it for in a certain neighborhood? It's a real value. Or a clustering problem. I've got data and I know how to group them. So when you think about artificial intelligence, think about this: classification, regression, or clustering, right? That's it. It's not true, and I'm going to tell you why it's not at the end. Now, when I'm talking about deep learning, let's think about neural networks, and that's very simple. Networks, in fact, are quite simple if you compare it with other methods. It's a linear combination of certain values at the outset and with a certain function, and it's given me 1 or -1. If it's 1, it's a cat. If it's -1, it's not a cat. And I can train it with many, many images of cats and non-cats. And I can adjust enormous parameters on that basis. When we talk about deep learning, we're talking about that. And there were lots of theoretical advance, and it's a lack of respect from me to talk about this, about people who have been working on this for a long time. But we have advanced in architecture, many, 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 many data, and many, many, many more calculation capacities, multiplying matrices much faster than than CPUs because they can do things in parallel. I come from an area, natural language processing. I haven't got a watch and I'm a little bit stressed, but I come from an area called natural language processing that is trying to understand what the language that we speak do and how we can convey it. We all know Siri and Alexa, and it comes from the 50s, in fact. It started with automatic translation, and it did very bad from language to Russian, and you can very well imagine in the 50s why it didn't go well. And it's evolved. Now, that area of natural language processing, which is a branch of AI, because it's something that we humans do and computers don't know very well how to do it, but we do it much better than before. And what's happened, and I've seen it in my career as a researcher in the past 20 years, is that a change in automatic learning, that nonsense of regression and clustering and so on, redefined. Not the task that we did, because the task was to identify what someone is telling me and translate it to a text, or automatic translation, or more atomic things, such as if I say a word in a text that I'm talking, whether that's an adjective or a noun or whatever. But since all those tasks, now look here, they can be defined as classification problems that are somewhat complex, this type of methods change the area completely, because they moved the levels of any task at level that was here, the level of knowledge, it went up here. When automatic learning appeared, and it went this high when deep learning. I remember when with Raul Larreta we were talking, this is a researcher colleague, he said, well, look here, when deep learning started, I mean, these are neural networks, it's the same thing, it's a rebranding, it's someone selling them. Is it really so? It came back into fashion, but because of the new capacity of computing and the capacity of data, and the new methods of training that would make machines more efficient, they went on being useful, but they were performing better, they were faster and better performing, and so that raised the level once again. Now, why am I telling you this? Because in between inverted commas, and I think the word's a bit strong, but it gives me some authority to say what I'm going to say. And I'm going to say it afterwards, because I think that automatic learning is changing the real world and how we can manage it. So I come from an area where automatic learning has changed everything, and I think that some things that I've seen happening can maybe apply to many other areas. It's happening in some areas, it's not in other areas. When we talk with our clients, you know, when they do vision through computers, you know, it's the same in cooperation, whether we are doing the same or more of the same, or can you tell me how much time I've got left? Ah, okay. All right. We can even make a break. Okay. Well, but I want to talk about the power of doing. I'm going to use this motto, really. Now, before anything, I would like to make please don't take any photographs of this. This is a traditional vision of data science. That's another word that we're going to be listening to for a long time. Now, data science, and this is a traditional view, is like the combination of computer science with its algorithms, maths and statistics with algebra, analysis, and so on, and probabilities. And this little drawing is the domain's knowledge. According to this definition, it's where you can find a specific domain, and this is a specific domain knowledge is applied to something. At the university, with some colleagues from the Computing Institute, from the Electro and Mathematics Institute, we are preparing a master's in data science along several lines that we've got there, including a professional subject and the change in the core subjects for bachelors, and it's including all these type of things in its core. it doesn't seem acceptable that an engineer doesn't know about discrete probability. It can't possibly be. It should be in the core. Just to give you an example, or algebra, or whatever. Now, the first thing we did, as we should, to define a master's is this master is about data science. And if you look it up in the internet, well, there is no universally accepted definition. And we started looking over it and see whether we agreed with this on the basis of our experience, and we got to something that is a little bit different. Not very different, but a little bit different. And so on the one hand, we left aside IT. No one doing data science can't be able to program. That person must know mathematics and statistics, but it must also know, and we introduce it as an area in the things about the things that we must learn, is visualization of data. And you know why this is becoming more and more important? Because data are becoming bigger and bigger. So if you have 14 data, you make a graph in Excel. But if you have 1 billion data, including 400 dimensions, then you've got a problem to draw it, because human beings have a little problem to see in more than 3 dimensions. I would say even in 2 dimensions. So, okay, never mind. Now, but the most important thing that we can draw as a conclusion is that the area of knowledge, unlike this scheme, is not one circuit more. It's everything where interaction occurs. The interaction we must know what we're talking about when we're talking about data science, automatic learning, our methods. Now, the important thing is what for. And it's, in fact, too arrogant to think that those who are doing IT, statistics, and so on, we know about that area of knowledge, and by definition, we don't. So let me give you an example. The fact that we sometimes don't know makes us make mistake. There is an article here that says that computers, trounced. This is the headline. It's the Stanford Medicine News Center. It says computers trounce pathologists in predicting lung cancer type and their severity. And this makes sense, absolutely. If I have thousands of examples of the same type of cancer, and they say this is this type, and this other type, and a computer will learn it easily. It's a problem of classification, and computers learn that very easily. We know how to do that. It's of course this is right. But look here, what doctors tell you, pathologists tell you, is that that's not important. They don't even come to an agreement about it. What they have to solve is not to identify things, but what it's the medicine, what type of treatment. And radiologists are people who publish. And so they're not only working, there are thousands, but they publish in industrial amounts. There are lots of radiological studies. And to think that you're going to solve their problem by using classification algorithms is arrogance. It's to understand things wrongly. It's to solve a problem that they don't have and underestimate the domain area. That's what happened with the processing of natural language. Oh, well, we would solve it with neural networks. Well, they would improve the performance of the tasks they knew, but for the new tasks they didn't know, because the problems went on being the same. So my first recommendation is have a friend who knows, and no, you're not the one who knows, and I'm referring to us in the world of technology. We have to make friends with those who are experts in an area and convey the knowledge. I don't mean the knowledge of technology, I mean the things that they can do. You have to make friends. You have to work in projects that can get you to do things together in certain domains. And I've seen several examples, and in the presentation, I think that you were working with a steel company. Now, those who know what the problems are, the ones who are in the domain in any area. Now, one of the most interesting things that have happened in the past few months at least from my standpoint in the region. There is a company from Cordoba, Argentina, which I know about because we've got quite a lot of relations in our group with Cordoba University. And Machinali's people are people coming out from that university, and they do automatic things, and there are consulting things, and mainly apply to e-commerce. Now, a month ago, it was bought out by Mercado Libre. Mercado Libre started using them to recommend what things to buy afterwards, you know, that famous question of recommendation. And it ended up by buying the company. And I think that's big business. I mean, from the little I know, that's big business for Mercado Libre. Very big business. Now, expect this type of things, because what's happened is that the owner of the business, the one who's got the model, the business model to make money, brings in people who knows, they make friends, and, you know, and they use it, apply to its business, because automatic learning is not a business model. Business models are business models. We still need a model, but automatic learning may help us a lot to improve our business, to make it work better, right? And that's what happened in the natural language processing. We've become experts in automatic learning without knowing that we didn't know about core things, but we had to really turn it around, because otherwise we were going to be left behind. Now, there is something that I haven't told you. It's not true from the researcher standpoint that it's only classification, regression, and clustering. There are many things that are happening. Let me throw some words if you're interested in reading about this, because we're going to go on talking about these things, and they have a different level of, you know, there are things that are mixed up. Transfer learning, I learn things in one domain and apply it in another domain because I've got more data here than there, and we're working a lot there. Word embeddings, it's changed the processing of natural language and how I can replace one word for the other. It's similar to synonyms. We've done this manually, but then something came up, and according to the concept, I mean, if two words appear in the same context, in some way they must be related, and several wonderful things have happened there, because it allows us to generalize well and understand things that are similar. General adversarial networks. AlphaGo Zero. Remember the little game? I mean, remember the computer that learned how to play golf, the most difficult game in the world? Well, you know, it learned how to play against itself. It didn't. It needn't the experience of an expert. It would learn and to win, and it lost, and it won, and it lost until it won. And won out the world champion. There's a link there with a lot of interesting information to know what's happening. Why do I recommend this? Because if I say it's, to simplify, it's simplification, regression, clustering, it doesn't mean that not a lot of things are happening, because it's fundamental to know what's happening, because this is coming at top speed. And so to be up to date is a key issue. It is fundamental to do. A couple of links more. The wonderful thing is that to learn is very easy. Millions of tutorials. If you want to learn, if you want to do, you can. You can. Let me tell you a secret here. The other day, I was Antel Arena was going to be complete, and we were talking about neural networks to classify cats and dogs, and we can go in and learn from the internet. But we've got a community of a vibrant academia in Uruguay, studying a lot of things, that has a lot to contribute. I told you about NIPS, that it was sold out. Well, there are two Uruguayans that are reviewers. Mauricio del Bracio has a place there as a reviewer. It's the same professor that we've got at the university, because he's among the 30 most important reviewers for that conference. He was born here and he teaches here. this is a site that we've got with some friends, and we talk about certain things. Modal claims. These are claims about things that may happen in a certain world, and we usually talk about, we post things about this type of things, about discussions that we know what's going to happen, whether, I think that there are two roads opening up now. AI will continue its path and trying to learn to understand what's happening with human beings and neuroscience, and a more complex road. And technology will include automatic learning as a technology, and we are going to be talking more about automatic learning than artificial intelligence. That my prediction is going to become a technology. The hype of AI as a term will stop, and we're going to be talking about automatic learning as something more concrete. So my final recommendation is the same that as Nicolas was saying. It's fundamental to stay open, to understand what things are happening, try to understand everything that we can do, instead of staying in your own circle, come out of the box, but also above everything, do things. It's fundamental. There is no better way of learning than doing. Thank you.